Okay, there is a question I keep on coming back to. If the internet's changing so fast, then what's actually changing underneath of it? I mean, like what builds it? Because the more I dig into this, or I dug into this, the more I realize something really surprising. The biggest shifts aren't happening in apps or in software even. They're happening literally under the ocean, inside chips, and in the physical infrastructure that most of us have never seen. So today we're answering one very big question. What are the top 10 technologies quietly rebuilding the internet? But first, let's talk about a company that is rebuilding one of the most important layers of it all, which is Meter. While everyone else is talking about AI models, new apps, Meter is rebuilding the layer underneath everything. And I'm talking about the network, not the networking like installing a router, the full stack from design, installation, cabling, security, and indoor cellular, all unified under intelligent software. So why does this matter though? Because as workloads grow, especially AI workloads, networks can't be something that you think about when they break. They need to evolve, and you need to think of them ahead of time. Now, Meter treats the network like a product. It's fast, private, resilient, and scalable. So if you want to see the future of connectivity, go check out meter.com/tiffintech. Okay, now let's answer the big question here. What technologies are actually rebuilding the internet under our feet, like literally under our feet? Let's start with something that feels almost impossible, which is coming in at number 10 is silicon photonics. So what if the internet ran on light instead of electricity? I mean, copper wires inside data centers are really hitting their physical limit, but silicon photonics replaces those electrons with pulses of light, which dramatically increases bandwidth and reduces energy use. Now, companies like Intel, Light Matter, and many others are leading this shift. Wired did a great piece actually on this. It's titled "The Future of Chips is Light." I'll leave the link here. You can go check it out. It's pretty incredible here. And the IEA estimates global data center electricity usage could reach 10% of the world power consumption by 2030, which is wild, 10%. So silicon photonics is one of the few technologies that is capable of preventing exactly that. Coming in at number 9, I find this one really fascinating. I mean, we've been talking about 3D printing for a while, and it's 3D chip packaging. So for 50 years, we made chips faster by shrinking transistors. But as the Washington Post noted, we're literally running out of atoms, or kind of anyways. Let me explain. We've hit the limit anyways. So engineers made a different leap, quite a big leap if you will, which is stacking chips vertically. Now, Apple's M series, AMD's 3D V-Cache, NVIDIA's H100, they all rely on advanced packaging. And IEEE, I don't know how you say it, they covered this, which is why chiplets are future of processors. And it's a really good article to look into. Really though, this redesign shrinks distances inside chips, massively increasing speed and efficiency. So it's worth checking out. This tech is literally going to revolutionize AI, if you will. Coming in at number 8 is QIC. So what if the entire internet upgraded its core protocol and almost nobody noticed? That's kind of what's happening with QIC, which is the foundation of HTTP. So, when you type in your website, you see that there. Cloudflare reports that over 75% of global traffic uses QIC. So why the shift? Because TCP, which was invented back in the 70s, really is struggling with mobile networks. I mean, things like packet loss and modern encryption. Now, Google's engineering blog explains why they built QUIC in the first place, so go check it out. I'm really trying to give you a lot of resources in this quick packed 10 technology countdown so you can really learn more about it. But basically, it handles modern networks far better. Coming at number 7 is AI-based routing. What if the internet could predict traffic jams before they happen? That's exactly what Google, Cisco, and Cloudflare are doing with AI-based routing. So Google reduced data center congestion by 40%, which is huge, using machine learning. This comes straight from Google's research paper, which is here. Now, Cloudflare is another huge company that is also shifting towards autonomous edge routing, which really turns the internet into a self-optimizing network, which is pretty cool when you stop and think about it. Coming at number 6 is zero trust networking. We've spoken a bit about this before. I think it's really cool. So imagine this. What if the internet simply stopped trusting anyone by default? Zero trust replaces the old, you're inside the network so you're trusted model. And Google pioneered this with Beyond Corp. And they explain in detail right here. You can check it out further. But basically what it is you are no longer, it's hard to tell now from a human to a bot, and they need a better way to do this. And that is where zero trust comes in. The US cybersecurity agency, CISA, has been pushing for zero trust for years. I mean, you can learn more about it here as well, but basically zero trust is really quietly, we don't hear about it a ton, but it's quietly becoming the baseline for security models for everything on the internet. All right, coming in at number 5 is low Earth orbit satellites. I am obsessed with these. I'm fascinated by them. So why did satellite internet suddenly go from terrible to surprisingly good? Because satellites now orbit at 550 kilometers instead of 35,000 kilometers. I mean, this lowers latency dramatically. Now, the Harvard-Smithsonian Center for Astrophysics, kind of a mouthful, maintains the most accurate Starlink satellite count, which you can learn more about here. It's pretty wild when you stop and think about it. And Amazon has some projects that are also building a competing constellation, which is called Amazon Kuiper announcement. You'll have to check it out here. So there's a lot of competition in this low orbit satellite space, and it's really rebuilding global coverage from space. I mean, we've seen Starlink do this, and now the competition is really ramping up. Coming in number 4 is edge computing. So what if your apps didn't talk to a server across the country, but across your city? That's really the idea behind edge computing. Now, Cloudflare's Workers platform runs code in locations within milliseconds of 95% of the world's population, which is pretty wild when you stop and think about it. So why is this such a big deal? Well, when you think about edge computing, it really offers an architecture that is what makes modern apps, and soon, real-time AI. We are continuing to move forward at such a fast pace with what we expect, how quickly we expect AI apps to react to us, real-time results. We're almost there, but edge computing will help us get us there much sooner. Okay, coming in at number 3 is post-quantum cryptography. So what happens when quantum computers become strong enough to break today's encryption? The answer is the world upgrades or needs to upgrade its entire cryptography, and early. Now, NIST spent years selecting new quantum-resistant algorithms. And it's pretty incredible because when you start thinking about how quickly quantum computers are moving, because they are moving quickly, we really need to take how that will affect our current encryption seriously, because quantum computing, as many of you know, has the potential to break modern or current encryption. Now, Google is already testing post-quantum TLS in Google Chrome. You can read about it here. It's pretty cool. It's something that's already in action and has been for a few years. This really, though, is the biggest security upgrade of the decade. So if it's of interest to you, security in general, I would highly recommend learning more about it. All right, coming at number 2 is smart NICs and programmable switching. So what if the humble network card became a tiny computer of its own? So that's exactly what smart NICs and DPUs do. Basically, NVIDIA explains this shift in their technical brief really well, where being able to offload storage, networking, and security. It really makes the physical internet programmable, if you will, not just the software running on top of it. It's pretty wild when you start and think about it. I'd highly recommend reading more about it, but it's a huge area where tech is growing. Now, coming at number 1 is undersea cable upgrades. So why are we not talking more about the most important infrastructure on Earth? In many cases. Because undersea cables, which carry, by the way, 99% of international internet traffic, they're invisible. I mean, not really, but we never see them on a daily basis. So this definitive report on this comes from the New York Times, how the internet travels across the ocean. So you can read more about it here. It's a bit of an older article, but I find it does a really good job of describing how it works technically. I have some videos on it as well, but it's really fascinating when you stop and think 99% of internet travels through these cables, and they're the size of a garden hose, or like your thumb almost, if you look at your thumb. It's pretty incredible. Light is traveling through them miles and miles. It's wild when you stop and think about it. So it's something that is going to, from Meta, Google, there's so many big tech companies now that are making their own internet traffic routes, so they have a bit more control over their own internet routes, which is pretty cool. All right, those are the top 10 technologies that are making huge waves and will continue to impact our future. Leave in the comments if you like these top 10 type videos. If you want more in-depth on one of these technologies, let me know. All right, I'll see you in the next video. Thanks, everyone.